Good evening, everyone. Today, we will discuss social circles of Facebook and how we use this and our lessons from this course. Our team consists of Guadalupe Aldana
Logan Fott, Josh Gillespie.
and myself, Andrew Vila.
Living in a uncertain time of COVID-19 and the pandemic, we are relying heavily on our information. And one of the biggest ways we get our information is through social media platforms like Facebook. So due to the large influence Facebook has on us, we want to learn, does Facebook help or hurt in spreading COVID-19 prevention awareness through its communities?
So, a little bit about the background and our motivation for research. COVID 19 is a disease that is caused by a new strain of coronavirus called SARS CoV 2. This illness first made headlines in late 2019 and ever since then has quickly turned into a global pandemic, according to the CDC. Since the condition is new, there is no medication guarantees to treat this illness. There's no vaccine, and that's why there is a high importance of information surrounding the virus. Since information is continually changing every day as we move through this pandemic, people heavily rely on media sources to get the most current information. Uh, they're looking for answers. People rely on their social media communities to receive information from their friends and families and um, from the communities they are part of. Um, Along with many social media platforms, Facebook is also faced with an urgency to combat the spread of coronavirus misinformation. The New York Times has found that more than half of the stories read on Facebook were coronavirus related. Facebook is a platform with over a billion users, allowing for a large amount of information to circulate. Therefore, it is essential to have the correct information circulating as the world fights this virus. The motivation came from the increase of COVID 19 cases worldwide and the news of the new information spreading about the vaccine that will soon be released. We analyze the data to understand if Facebook is helping or hurting the spread of the virus.
So a little bit about the data. The data we analyzed is from Snap Group from Stanford University. To use this data, we downloaded Facebook underscore combine.txt.gz and ran this data through Python. This data is a list of friends of Facebook friends, and it within it shows communities. So with those communities, we're hopefully able to see how information runs throughout the communities and better understand the results of this experiment.
So a little bit about our research methodology and the tools and techniques we used. Like Joshua just said, we downloaded a Facebook underscore combine.text.gz, which was taken from Stanford's network analysis course. I'm sorry, from their work. And we implemented that into our knowledge of our social network analysis course that we're currently taking this semester. With this combined knowledge, we were able to program in Python in Google Collaboratory our results. Um, Google Collaboratory was chosen for our Python coding language because of its ability to be used online and to be used by multiple of our teammates at the same time, creating a better cohesion and a better um, speedy and readily easier way of programming and getting our results easier and quicker. In order to digest the information visually, we downloaded and utilized iGraph, GraphTool, and what we've been using for the majority of our course, Network X, into Python to better understand and visualize our information.
So on this slide, we have a few snippets of the actual coding. So on the far left is the general information. As you can see, the data has 4,039 nodes, over 88,000 edges, and the average degree, the number of nodes a particular node is connected to, is around 43. Up in the middle, you'll see the degree. This is the degree of node zero. So the degree of node zero is 347, connected at 347 nodes. And then below that, we have the betweenness centrality. That is showing the influence of a specific node within the community.
To better visualize our entire data set from Stanford University, we took everything and plugged it into iGraph to create our whole graph that we have visualized here. As you can see, the nodes are the individual green dots, and the edges between each node are visualized by the gray lines. As you can tell, even between communities, inside communities, from other communities, from individual nodes to each other, information spread is vast and great. Data flow is very high, and this is of great confirmation for us. However, we cannot comprehend this information data flow. We do not understand it better. We do not know how it works very well. And we cannot come to our ultimate conclusion as to Facebook helping or not. So from here, we had to further digest and analyze in other tools and techniques this entire whole graph.
So to sort of simulate how information travels through the graph, we ran the shortest path between two random nodes. The two nodes we selected were node 700 and node 2500. And as you can see on the graph, it's very complex, a lot of detail, but there is, if you look closely, 8 red dots on the graph, and that is showing all the 8 nodes that it ran through from 700 to 2500.
Here we decided to visualize to see how random nodes within our data set of 4,000 nodes and edge lists, how each of these random nodes within this data set can connect to each other. Um, so for this, we used about 50 data points because we realized the bigger we had of the subgraph, the easier it would be to visualize possible connections between these random nodes. And as you can see, we have a few connections. Even though the majority are not connected, there is a chance that even amongst random nodes as seen in the subgraph, there are possible connections. And here we visualize it with iGraph.
Lastly, this graph is illustrating the communities. So within this data set, there are 13 major communities. And through our experiment, we have learned that data and information travels fastest through communities. So within those 13 communities, data is traveling very fast. And there's just few nodes that connect one community to another. So in the case of a pandemic, isolating one community could help or hurt the rest of the communities.
In conclusion, we have discovered that data flows through communities between a centrality and random nodes, and that no matter what happens, even between large sets of communities, as described by Joshua, information flows readily between them, and removing one community or another can actually stop the flow of data. Between a centrality, a single node is an influencer to multiple other groups, to multiple other users. Um, the random node, node 0, had 300 plus connections. This information could spread wild from one single point, or information could spread from one to another through this single point. And as we discovered through the subgraphs, random nodes can allow information to spread randomly from one point to another. Information and misinformation can spread very quickly, is what we discovered. However, at the end of the day, we cannot prove that Facebook, as a social media platform, is helping or hurting to stop the spread of the virus. We cannot determine if there is corporate censorship or promotion of health guidelines within the small data set that we used. In the end, we could not solve our problem, but we have discovered that data does flow quickly and at great speeds. Thank you so much for joining us on our little experience, and we hope you've learned something as well. Thank you and good night.